Okay, so we have exponential equations and logarithm equations, and as I said yesterday, we talk about solving equations and solving inequalities. Okay, solving equations and solving inequalities. I think to make it clear, let's do that. Equation and inequalities. Okay, equation and inequalities. We have two types. Okay, we have two types. One type for equation is have same base. Well, I mean have same base, they can have same base. Okay, you can make it into the same base. And the other type is cannot have same base. Inequality is the same. Same base cannot have same base. Okay, this what I talk about here is exponential equation and inequality. Okay, this is exponential equation and inequality. Well, it's not in the middle. Exponential. Okay, exponential equations and inequality. So basically we have two types, equation and inequality. Equations can have same base, equation cannot have the same base. Inequality, equation can have same base, inequality cannot have same base. Okay, so well, if we have the same base, we equalize the power. We'll do questions, but this is the theory. Okay, if they have the same base, we can equalize the power. This can be any base. Okay, they can have base greater than 1, in between 0 and 1, doesn't matter. Okay, they have any base. If they cannot have the same base, we solve by log. Okay, we solve by log. So the power equals to log base of the answer. Okay, log base of the answer, we solve by log. Inequalities, they have the same base, but there's a well, it's not really you must do that, but it's easier if you can remember this. If they have the same base greater than 1. Okay, you don't have base in between 0 to 1. Well, you know, if your base is in between 0 to 1, you can flip it and make the power of -1. You can make it into the base greater than 1. So when we have the base greater than 1, so for example 3 to the power of x greater than 3 to the power of 2x minus 2, then we can compare the power with same sign. Okay, we compare the power with the same inequality sign. So if left hand side is larger, right hand side is smaller, we still have the same inequality sign for the power. But the requirement is the base must be greater than 1. Why the base must be greater than 1? If it's a base less than 1, in between 0 to 1, it's a decreasing shape. Yesterday what we learned, the shape is a decreasing. 3 over 4 to the power of x is a decreasing graph. So if the answer left hand side is greater than right hand side, then the power needs to be less. So you need to flip the sign when the base is not greater than 1. Therefore, we will just compare we want to use the same sign. We don't want to think about the flipping sign. So we make the base greater than 1. We can make sure that you can definitely have the same sign. But like it's complex to solve inequalities, you can't have the same base. For example, 2 to the power of x greater than 4 to the power of 3x minus 1. So something like that, you can't make the same base. So you need to use log both sides. You log a both sides. Okay, you log a both sides. Okay, what you choose for a? Well, you can choose a. A can be any number actually, but again, we want to keep the same sign. We want a greater than 1 as well. Okay, for inequality, we need the base for both log and exponential to be greater than 1 to maintain the same direction of your inequality sign? Well, what you choose for the A, it depends on what you have. Okay, it depends on what you have. So I will talk about more detail in the question, but this is the theory. You log A both sides, and you want A to be greater than 1 to keep the same direction of your inequality sign. So that's basically for exponential equation and inequality what we should do. So let's have a look at these questions. Okay, let's have a look at these questions. We go through that in questions. So example 2. Where's my example 1? Here's my example 1. Okay, example 1. 4 to the power of x equals to 256. Okay, equals to 256. Well, you can see 56 is divisible by 4, therefore this number must be divisible by 4. Okay, that's the tips how you can see whether a thing can be divisible by 4. So you look at the last 2 digits. If the last 2 digits divisible by 4, then everything is divisible by 4. So, well, I don't know. If you don't know, we can divide 4. So we have, well, that's the 16 0, so it's 4 times 64, and we want 4, right? 4 to the power of something. So 4 times 16, right? That's what we have. So we have 4 times 4, that's 4 to the power of 4. Okay, 4 to the power of 4. So 4 to the power of x equals to 4 to the power of 4. That's the first case. We can make both sides to have the same base, which is 4. So therefore, we have x equals to 4. We equalize the power. We equalize the power. X equals to 4. Okay, next one. We have base 5 here and base 25 here. So basically, we can make 25 become a base 5. So that's 5 2x minus 4 equals to 5 to the power of 2, and then to the base of minus x plus 2. So now it's a base 5. So 5 2x minus 4 equals to 5. You times the power. So that's a minus 2x plus 4. Now both sides have the same base. Okay, both sides have the same base. We equalize the base. So 4x equals to 8, x equals to 2. Okay, x equals to 2. We equalize the power. If they can't have the same base, we equalize the power. Okay. Okay, 2 to the power of minus 3x, and the other side have 1 over 64. So, well, 2 should be the number like or a half. Well, if you like, you can make a half. Well, how if I make a half? Well, I can do both ways. If I make it a half, this is actually 1 over 2 to the power of 3x. You see that? The minus 1. You minus 1 first, that becomes 1 over 2 to the power of 3x. And this side will be 1 over 2 to the power of, okay, 32 is to the power of 5. Then it's to the power of 6. Okay, to the power of 6. So now we have same base. For equation, I don't need the base to be greater than 1. I can have any base. Greater than 1 or in between 0 to 1. That's all good. So a half is good. What I can do is 3x equals to 6. They have the same base, which is a half. Now I equalize the power. I have 3x equals to 6 and x equals to 2. Okay, x equals to 2. Well, these are really basic, simple questions, but this is the method how you should do it. Okay, this is the method how you should do it. And now we have a special question for example 2. This appeared in VC exam for couple of times, okay, for short answer, part 1 exam, no cast part. So it appears a couple of times, but it's not always like that, okay, it's not always like that. This is one form, which is like exponential question. It looks like an exponential question, but you can see 9 to the power of x and 3 to the power of x. What's the relationship between them? If you just look at those two numbers with x, what's the relationship? How 3 to the power of x become 9 to the power of x? 3 to the power of x to the power of 2. You will have 9 to the power of x, right? This is how you recognize what type of question is that. When two terms contain x, one is the square of the other one. That's this type, okay? That's this type. So what we should do, 9 to the power of x is 3 to the power of x, then to the power of 2. So we can write this all in terms of 3 to the power of x. Okay, that's how you say, oh, which type is this question? So you see the terms contain the variable. One is the square of the other one. So we use this method, is we let the smaller one become a. Okay, we let the smaller one become a. So what we will have is a squared equals to 12a minus 27. So a squared minus 12a plus 27 equals to 0. This question becomes quadratic equation. Okay, you can convert this complex exponential equation into the quadratic equation. So it's a minus 3, a minus 9 equals to 0. So a equals to 3 or a equals to 9. Let's keep going and ask you a question. So you are solving for x, not solving for a. You need to put a back into 3 to the power of x as well. So 3 to the power of x equals to 3 or 3 to the power of x equals to 9. So x is 1 or x is 2. All right, let's do another question. Okay, let's do another question. I will just write another type, which looks totally different, but it belongs to the same type. So if I go for x equals to x plus 12 root x equals to 27. Wait, I can't go for 27, 6. I will go 6 here. Okay, that's the question. Okay, last year there's a similar question in the SEC, which is required you to solve for this. Okay, a similar one, okay, involve x and root x. And they want you to use a method to solve for it. Let's have a think. How I can recognize this belongs to this type? One is exponential and the other one is just x and square root x. What we should do, like, you need to use like familiar questions to solve unfamiliar questions. So this one, you can see the two terms contain the variable. The x and root x is the square relationship. You square root x, you will have x, right? So that will belong to this type. We will let the smaller one become a. Okay, let the smaller one become a. So x is actually a squared plus 6a minus 27 equals to 0. So it back to a quadratic equation as well. Okay, back to a quadratic equation as well. So you will make a plus 9, a minus 3 equals to 0. Right? Yeah, that's right. A.
No, I was reading the 7 as like a bracket. Minus 2. Okay.
Plus 9 minus 3. And my a will be negative 9 or a will be 3. All right, my question is, what is the x? Well, it's just last step. What x belongs to? What x equals to? Anyone? Just say the answer. 9? Do we have 81? Do we have 81? Well, we have two answers, right? We have two answers. A is root x. A is root x. Well, root x equals to 3 and root x equals to -9. If I square both sides of this, I will have x equals to 81. But do we have it? Should we keep that answer? No. Okay, answer is no. Negative. Root x can never be negative. The a can't be less than 0. Okay, a can't be less than 0. Because root x equals to -9, that's a wrong statement. We don't have it. Your root x can never become -9. Well, if you square both sides, you have your x equals to 81. Root 81 is 9. It's not going to be -9. So this is not achievable. Okay, so we don't have that. When you solve this type of question, the a you give can solve more than the answer you need. Okay, for example, this one, you have negative values, but you shouldn't have negative values. You need to reject that. Same as that side. If you make this a equals to 3 to the power of x, this a can only be positive value. Can't even be 0, because 3 to the power of x is not going to be 0. So it's 0 above. So your a can't be negative or 0 for this a. Okay, so when you solve your x, you need to be aware, is that achievable? Like when you write the statement, root x equals to -9, is that really achievable? It's not achievable, so we don't have that one. That's the extra solution. Okay, it's the extra thing. We don't have it. We only have x equals to 9 here. Okay, we only have x equals to 9. Therefore, in this question, only one solution. Okay, only one solution, which is x equals to 9. Okay, can you see like they looks really different? And this question is actually not belongs to exponential question. Like it's not exponential ability. It's not really testing exponential ability. It's testing you, can you replace some variable into another one and then solve as a quadratic. So it's actually a different ability. It belongs to the exponential topic, but it's not really testing your exponential ability. So this question and that question are identical. Okay, they are exactly the same. They can have more type. Well, this is x and root x. This is like 3 to the power of x and 9 to the power of x. You may have some other ones. Okay, you can have some other ones. For example, 1 over x and 1 over x squared, something like that. So you need to use your own thinking to think about which question belongs to this type. Right, that's this one. And if you can go to page this page 5. Well, this is exponential equation. Okay, this is exponential equation. So we have exponential equation, but we don't have the same base on both sides. 2 and 11 can't become each other. So we need to use log to solve for it. Okay, we need to use log to solve for it. So x will be log to 11. Okay, x will be log to 11. That's it, done. Well, next one, 3 and 28. You can see they can't become each other. So 2x minus 1 will be log 328. I know like a lot of you like to do change of base, trying to change it to base e or base 10, but now we don't do that. If you have log 328, just leave as log 328. You know the reason why we use change of base formula like at very beginning, like long time ago, we do change of bases. The calculator at that time is not that powerful, and they can't calculate other base. They can only calculate base 10 or base e. Like in the calculator, they only store those values. So that's why when people want to evaluate that, they need to go, oh, log base 10 28 divided by log base 10 3, and then I can see the value. I need to do that extra step to evaluate. But now the calculator store all the values. They do change of their base by themselves. They can do it by themselves. I don't need to do it. So you leave your answer like that. It looks better. Think about if you use change of base. Log 10 28, log 10 divide log 10 3. It looks really complex. So don't do that. Not necessary unless the question asks you to do that. So we have 2x equals to log 328 plus 1. So x will be log 328 plus 1 over 2. That's the exact value. You just leave your answer as the exact value. Well, if you really want, to make it look, well, I don't think it's really better, but like if you really want to do something to that, I can make 1 to become log 3, okay, 1 is log 3, and 2 is log 3 to the power of 2, which is 9, right? How I make that? Log 3 to the power of 2, that's 2 log 3, that's 2 as well, so it's log 3, 9. So I can do a further step to make x equals to, well, why divide it? I can't do much about it. Can you see that? That's a log 3. I can times those two. 84 here, divide by log 3, 9. Okay, can you see we can't divide 84 and 9? That's a wrong way to use the formula. It's only you minus and then you can when you minus outside, you can divide inside. But what I can do here is, not sure if you can see it, but what we can do can become a log 984. I use the change of base formula reversely. Okay, this is like log 984. I can make it change base to change base of 3. Okay, and then that becomes log 384 divided by log 39. So now I can use it reversely, make it log 984. But it's totally not necessary. I can just keep my answer as this step. Okay, I can keep the answer as this step. So what I'm doing here is just show you how all the log formulas can be used. Okay, so when you add them, you can times the number inside. When you have log same base divided by log same base, I can reversely use the change of base formula to make it into 1 log. So that's just log 984. Not necessary, okay? You have the danger to get something wrong in between and lose the mark. So it's good enough to keep your answer like that. Okay, that's page 5. When you solve equations but you can't have the same base, what you should do. And if you can keep going to the next couple of page, where is it? Here, 5G, page 9. Okay, can you see those 4 questions? They can all have the same base. Can you see that? They can all have the same base. Base 3, base 3, base 2, base 3. Well, some of them are 1 over 3, but remember, for inequality, I don't want base less than 1. I only want base greater than 1. So for those 4 questions, what I can do is, that's 3 to the power of a half x plus 1 greater than 3 to the power of negative 3. Okay, now they have the same base. We can just compare the power, and it's the same direction of the sign because your base is greater than 1. Okay, because your base is greater than 1. If your base is not greater than 1, you can't do that. So that's what I should do. Okay, I'll skip 2 first because 2 is the most complex one for exponential solving, inequality solving. Let's do 1 and then let's do 3. Let's do 3. That's 3x minus 7 greater than 3 to the power of 2, and then to the power of minus 2x plus 8. Make it all to base 3. Now they have the same base. I can just compare the power. Okay, that's what we have. Just do one more. Don't do 5 yet. I also change the question for 5. Make it a little bit harder. Let's do 4. 4 is 2 to the power of minus 3x plus 1 less than, well, 16 is 4 times 4, 2 to the power of 4. So it's 2 to the power of negative 4. So minus 3x plus 1 less than minus 4. Minus 3x less than minus 5. Okay, when you divide things or times things for inequality, you need to be really careful. So I need to swap the sign in this case. Because I divide negative 3 on both sides, I need to swap the sign. Okay, flip the sign. So divide by minus 3 here. Okay, those 3 questions are quite easy. So they can make to the same base and easily solve the inequality. Okay, let's change 5 to, okay, I'll change this number to 28. I'll change this number to 28. Well, after I change it to 28, what you can realize is you can't have the same base, right? You can't have the same base. So what I should do is, I'm still trying to make everything into a base greater than 1, okay? Into a base greater than 1. So I will do 3 to the power of 4x minus 2. That's equals to that. Okay, minus the power at the bottom, I can flip it up. Okay. Now what I should do after the step is I will log both sides. Log base A both sides. But what I should log, what number I should choose? We should choose it really clever. Well, I can do any base. I can do log base 10, log base E. Well, it's all good. You will have the answer in the end. But what I will log both sides by is I will log 3 both sides. Okay, why log 3 both sides? Can you see we can directly have this 4x minus 2 out. And this side is still log 3, 28. That's what I should do. Because you drag this power into the front and we left log 3, 3. Log 3, 3 is just 1. Okay, so we just have 4x minus 2 on one side. And the other side, log 3, 28, is a number. Okay, you log base 3. That 3 is greater than 1. So the inequality sign won't change. Okay, the inequality sign won't change. If you log base, for example, log base 0.2, you need to flip the sign. Because that's a base in between 0 to 1. We haven't learned the log graph. If you learn the log graph, you know when the base is less than 1, it's a decreasing graph as well. So that's why we need to flip the sign. Okay, that's what we have. And then we have 4x greater, less than or equals to that plus 2. So x is less than or equals to log 3, 28 plus 2 over 4. Okay, that's how you solve inequality when the base is not the same on both sides. You log something on both sides, but what number you choose? You will choose the same base when it contains the variable. Okay, choose the same base when it contains the variable. Okay, after we know this, let's go to the top. Okay, before we do this question, I'll give you something. For log, you don't know it's by just looking at it, it's all positive. You can't see whether it's a negative or positive. So when it's negative, when it's positive, you need to be aware of that. Okay, when A and B both greater than 1, or both in between 0 to 1. Okay, both greater than 1 or both in between 0 to 1 is positive. When 1 is greater than 1, 1 is in between 0 to 1 is negative. Okay, when they both greater than 1 or when they both in between 0 to 1, that's a positive number. When 1 is greater than 1 and the other one, well, anyone, okay, if A is 2, B is 0.5, or when B is 2, A is 0.3, they are negative numbers. Okay, they are negative numbers. So that's how you see whether log is a positive or the value is positive or negative. You just look at it, log 3.2. How I can know that's negative? Like you know by this, or you can know by graph. We haven't learned graph yet. Well, you learned it last year. I think you may forget. That's easy to remember when it's positive, when it's negative. So, okay, I'll show you two methods. Well, not two methods. It's actually the same method, but you choose the one you feel is easy. Okay, 0.7 and 0.3. Obviously, it's not greater than 1 and can't become the same as each other. Well, I should actually choose log 0.7 both sides because I can get rid of the 0.7 like on the left hand side. But if I log 0.7 on both sides, the sign will flip. I'm not sure if you can remember this. Okay, if you can remember, what we should do is log 0.7, 0.7 minus x plus 1 greater or equals to log 0.7 of 0.3. Sign will flip when you choose a base not greater than 1. Sign will flip. But it's easier after that. This side will be minus x plus 1 greater or equals to log 0.7, 0.3. Okay, I'll times the minus 1 on both sides. Sign will flip again. I times the minus 1 on both sides. Sign will flip again. And x is less than or equals to 1 minus that. Have a question. Is this a positive or negative number? Is this a positive or negative number? The thing in red. This one. Positive? Can you see that's positive? Because both number 0.7 and 0.3 is in between 0 and 1. So this number is greater than 1, greater than 0. Well, I'm not sure whether it's greater than 1 or not. Like I can't see that yet. But I can definitely see that's a number greater than 0. Okay. positive number greater than 0 because both number is in between 0 to 1. That's what I'm talking about here. Okay, that's what I'm talking about here. How you can see whether a log is positive or negative. That's positive. Both number in between 0 to 1. That's the first way we can do it. If you can remember, when you log 0.7 on both sides, you need to flip the sign. That's what you need to remember. But if you can't remember that, you want to make it safe. So I will log anything greater than 1 on both sides. I will log 10 both sides, for example. The sign will remain the same. Well, let's make it obvious as well. The sign will remain the same. Okay, compare that. 1 is log 0.7 on both sides. That's we need to flip the sign. But when we log 10 both sides, we keep the sign as the same. When we keep the sign as the same, what we will have is right, I drag the power into the front. I will drag the power into the front. That's what we will have. Okay, so minus x plus 1. I will divide log 10.7 on both sides. Okay, we divide by this number. We need to be careful with this number. We divide something inequality. Is this a positive number or negative number? Come on, negative, right? 1 greater than 1, the other one in between 0 to 1 is a negative number. So sign will flip here. Okay, sign will flip here because it's negative. Okay, that's most of students will get wrong because they can't see it's negative. It really looks like a positive thing. We divide it without any thinking, just divide, but it's wrong. The sign will flip here. Okay, after this step, I really don't like to see log 10.3, log 10.7. So what's that? If you use the change of base formula backwards, that's a log 0.7.3, right? The bottom is the base and the top is in the bracket. So it's log 0.7.3. We use the change of base back. So what's change of base? Log AB will equals to log CB over log CA. Right? That's change of base. So what we apply here is from log CB to log CA, we make it back to log AB. It's in the previous page. The rule is all in the previous page. Don't really need to copy that. You just need to know how to use it. So we minus both sides, sign flip again. And we plus 1 on both sides. We end up with the same answer as the right hand side. But we do much more working here. If you can remember at the very beginning, if you log something which is not greater than 1, we need to flip the inequality sign. If you can remember that, you can choose number 2, which is really quick to do, okay, which is really easy to do. You can see it's only need 4 lines, but here we flip back, flip again, we change of base formula, we do a lot of extra things here. And that's the 2 ways we can, well, it's same way, okay, same method, just depends on what base you select at the beginning. Alright, but we don't do that question. We have this question before already. We don't do that anymore. That's graphing. Okay, so that's it. So everything we learned today, we finish everything for exponential. Exponential graphing, exponential inequality, and exponential equation. So that's everything for exponential. And what we learn tomorrow will be logarithm. Okay, we'll start logarithm tomorrow. So everything clear for exponential. What I want you to do for the rest of the time is, if you're not familiar with the rule, can you go back to page 4 to go through all the rules here. You don't need to see the proof just for fun, put there for you. If you like, you can have a look. If you not interested in that, don't look at it. You have log 1, log 2, 3, 4, and extension and change of base. Okay, so 7 things in total, maybe 6. What I want you to do now is do example 1, 2, and 3. Okay, page 4 and 5, example 1, 2, and 3. You should be able to finish that in 20 minutes. If you really can't remember the law, I highly recommend you go to revise the law now and then do the question.